Hello everyone, I welcome you at our talk about a managed CF as a service. It's a cookbook for an operator.
Hi everyone, my name is Fabio Berchtold. I've been working for the past 5 years as a cloud engineer for the Swisscom application cloud, and mostly we've been working extensively with the open source cloud foundry there. We use Concourse, a ton of different BOSH releases, and of course BOSH itself. I've also been a Cloud Foundry ambassador in the past, and I'm also a very passionate Golang developer as well, and of course contributor to various Cloud Foundry projects during that time. And I also really like and enjoy building new BOSH releases for fun, experimenting with new kinds of software and systems, so yeah.
So, as I said, my name is Andrea. I've been working for Swisscom now for 3 years. I started as a cloud engineer in the infrastructure team, which was based on OpenStack. But when Swisscom decided to change their provider, I decided to change to the bright side of life and joined the Cloud Foundry team. So, I love to automate things. That's why I recently worked hard on the self-developed testing suite. We will talk about that a bit later as well. So let's start. So let's have a short view on the Swisscom application cloud to give you some necessary background information for the upcoming topics in this talk. The Swisscom application cloud is our own custom platform as a service offering, which is based around the open source version of Cloud Foundry. We have a public offering which is available to anyone. You can just go to developerswisscom.com, register, and start pushing your apps there. And we also have the private offering, the virtual private offering for companies. And we interconnect. We have their own managed platform as a service installation within our data centers, and it's actually interconnected within the company's data center and its private internal network. So this interconnectivity is actually one of Swisscom's specialities. We also have a variety of service we offer through our marketplace. It consists of the usual suspects like MongoDB, Redis, MariaDB, and so on. All of this is basically one Cloud Foundry installation stretched over 3 physically different located data centers, and those are spread over 3 availability zones, as you can see on the picture. Those are all managed by BOSH. I think with that in your backpack, you're now ready to join us on our journey about the experience we made as a true DevOps engineer maintaining and engineering the whole platform with only a small team, because we were only 3 people, and just lately we were 4, and just a week ago a new team member joined. So we were managing that for a long time only with 3 people. And it's also maybe surprising to know that's about 16,000 VMs. So as you now get a general impression how our architecture looks like, I will try to explain you how our services are integrated in this landscape. You see on the picture that we have 3 example tenants. There are different foundations, and all services are existing within this tenant. There is also a service broker. It's deployed as an app on top of Cloud Foundry. And as we have like I forgot about that. We have like the container-based services, which are deployed within the Kubernetes, and also the BOSH-based services, which are deployed as VMs. As you can see, this setup is still currently in use, but it brings a few pain points. For example, we produce the services many times, but we can't consume them from everywhere. So they are tightly coupled to the CF. And to overcome these pain points, we came up with the idea of centralized services. That means we produce the service once and can consume them from everywhere. In other words, that means that the services are fully reusable. You can imagine this in 3 layers. I try to explain it from a technical point of view. The first layer are representing the consumers. This can be anything, a cloud provider, a user, whatever you can imagine of. Then the second layer represents the interconnect and the brokering, which consists of a data plane and a control plane. There is also the OSP API as part of it. It's responsible for the service exposure. And the third layer are the producers, and this can be anything who produces a service like RabbitMQ, S3, Oracle databases, whatever you can imagine. And the goal is that in the end, every produced service can be consumed from everywhere and not only within the app cloud. So, well.
Okay, does it work? Yeah. So a few things we learned over that time is, for example, you should build your BOSH releases when you build them to be as self-contained as possible. What that means is you should not have your BOSH release or your deployments rely on any components or infrastructure that needs to be there beforehand. So when you build something, it should be like as easy as possible to reason about this deployment and not have any external dependencies. An example of this is our self-developed task scheduler BOSH release. It's basically one deployment with just one single instance group of VMs, and everything is co-located within. It has like a service broker on this VM, the distributed cron backend. It has like the task runner, which interfaces with Cloud Foundry to run tasks, also co-located. It has BBR scripts for doing backups. We have a backup manager called Backman, which is also co-located and takes care of managing and running these BBR scripts. And we also make use of the route registrar to register the service broker on the system domain of Cloud Foundry. So this is everything is included within just one deployment, and it makes it easier for our operators to not have to reason about on how this works with what other components and so on. So the lesson learned here was that, the more complex you make a deployment, of course, the more problems you're going to have or might have. Also, something we learned is that not everything needs to be an HA deployment, actually. Sometimes it's enough to just have a single instance of a proven RDBMS. You don't always need a consensus algorithm-powered clustered system. An example of that would be, in the past, we've had quite a few issues with the Galera from CF MySQL, actually. And over time, we've migrated a bunch of our backend systems from this Galera to a single Postgres deployment. And since then, it has been much more robust and stable, actually. Even if it's just a single instance. I mean, sometimes even a single SQLite file can be enough for your needs. You don't always need an HA solution. And we've done that also with the BOSH director. In the beginning, we had the BOSH database externally hosted, also on a Galera, but this has been quite problematic. We had issues with connection loss and with Galera itself. And at some point, we decided we need to migrate back to the co-located Postgres on the BOSH director, just with the addition of our automated backup tools. So the gist of this is you should design your BOSH deployments to be simple but robust. It works. Another example of this is the aforementioned Backman BOSH release that we developed. This is basically also a self-contained BOSH release. It just contains like one job, which is the Backman job that you can co-locate onto any other BOSH deployment. And it's been built to take care of and managing the BBR scripts. So what this Backman component does is it runs the BBR scripts based on a cron-tab-based schedule. And it packages up the BBR artifacts and it archives them onto S3. And it also takes care of these backup files on S3 based on a predefined retention policy. Yeah, so it's an example of like a small but very simple component that just does one thing and does it well. It's completely batteries included solution that has no needs for any external interaction whatsoever. It doesn't need an agent server-based system or anything else. You simply just collocate it on any deployment that provides you with a BBR script and it will just work. Yeah, so you should always try to take advantage of the functionality BOSH actually gives you and not be fighting against it. So in this case, taking use of or using the simplicity of the BBR concept and the ingenuity behind it. Yeah, and as I've mentioned earlier, we've by now also co-located this thing on our BOSH director to take care of the BOSH database. We've co-located it to basically anything that has BBR scripts, our Galera, Postgres, Consul, CredHub UA, basically almost anything with a state now has this component co-located. Yeah, so another thing we learned is pretty early on that we need to have some kind of way to track releases and their versions. We needed to have some kind of a proper release management system. And what we did is we invented what we call cloud releases. It's kind of you can think of it as a metadata repository which tracks all these different artifacts like BOSH releases and their versions, Docker images, stem cells, build packs, anything, you name it. We have like build and test pipelines in our lab environment. They track all these artifacts from upstream, either from BOSH.io or GitHub or our own internal GitLab. And so they track these, they build it, they run functional and unit tests. And if it's successful, they will add it to this metadata repository with the version info and everything needed. And then at some point in time, we can decide to cut a AppCloud cloud release, what we call it, out of these versions, where we specify the different BOSH releases, the versions they have, and all the artifacts bundled and packaged together. And we promote this to our integration test environment. And there it will be automatically deployed. It runs some integration tests, end-to-end testing is done. And if it passes this stage, we can say, yeah, this is a valid cloud release. This is something we can use in production if we want to. So we could promote this cloud release in the end to deploy it on production. This step is still intentionally manual at the end because we want to have control over which release gets deployed where. But basically, once it has passed the integration testing stage, we are pretty confident that it will work in production. It's really important to have some kind of a release management system to be able to confidently reproduce for like 100% reproduce and redeploy always the same versions in every environment. So you're confident that you can always do the same thing everywhere. Because this is one of the things we actually do is all our environments that we manage for our customers, they have exactly the same versions of Cloud Releases and Cloud Foundry and all these components deployed. We try to not deviate anywhere. Everything is really the same thing. We have the same pipeline everywhere. With the click of one button, it just gets deployed, and that's it. Yeah, so since we have these cloud releases, this has become a pretty integral part for us, and its importance that in how it helped us, it cannot really be understated. It was actually very useful. We've expanded upon these cloud releases with basically all our tooling and pipelines we've built. So we created a dashboard for these cloud releases that can show which versions of BOSH releases or stem cells or whatever a specific cloud release contains, all the metadata around it. It even shows us which software versions of any particular software is contained within a BOSH release. We also have a kind of an automated way to track the software inside a BOSH release. And this is all shown on this dashboard, and we also see which cloud release has been deployed in which environment at what point in time, so we can see the history of everything. We've also built an ops tool that we call AMC. It's kind of a Swiss Army knife CLI tool that we've made, and we've basically crammed everything we could think of into this one tool. So this tool has knowledge over the cloud release, metadata, and it knows how to automate everything within our environments, basically, from the deployment process itself, handling loggings into system, any interaction with any system or component, and basically everything is done through this one tool, either from the pipeline or from an operator manually, since it's a CLI tool. So we've abstracted everything into this. There is actually, we had some issues in the past, for example, when we used the CF deployment or the BOSH deployment directly from upstream, all these templates and ops files, and we were just using normal BOSH CLI commands directly. We started messing up things, or it has changed in the meantime from GitHub. And so we were like, we have to put this into this tool, because this tool has all the knowledge about the releases and their versions, and it knows exactly what needs to be deployed in which step and where and so on. Basically, it knows everything that needs to be done. So we tried to take away this mental overhead from the operator, so you can just use the tool and it will do everything the same in every environment the same. This was also important, that we have like 100% reproducible deployments in every environment. Yeah.
Well, I have to warn you, maybe you do it differently, but we don't use ops files or upstream templates at all. We do really our own templates, and you may wonder why this really makes sense. So for us, the really main point is that we have 100% flexibility in what we do. We can do everything we want, and yeah, we're not restricted to anything which is upstream. And the other point is, and maybe you also see that different than we do, but if you do your own templates, then you're really forced to understand what you're doing, what the specs are, what properties you have, and how they're going to behave in the end. So from our point of view, it really makes sense to understand what you deploy and to understand the BOSH releases you have, to also have like the 100% control over what you do. This goes strongly hand in hand with the release management. From the release to the deployment strategies, we also learned a lot in our journey in the past few years. When you start to build up such a platform, it may work out to not have like a perfect engineered deployment strategy, but with the environment growth and with the complexity of that, the components changing continuously, I really recommend to have like a stable and flexible deployment process in place. I think if you do that properly, then you really reduce the operation overhead massively in the end. So we have here a few recommendations from our side, what we learned. And you see the first point is a deployment shouldn't contain more than 100 VMs, but how can you leverage that? So yeah, if an environment grows there, you need probably more than 100 VMs. So what we did in this case, we just split the Kubernetes and the Cloud Foundry into management and cell blocks. And the cell blocks, each cell block then contains a max of 100 VMs. The other point is use a continuous thing doer to orchestrate that whole thing. And what we do, we count on concourse at this point. And I will show you in the next slide how a pipeline from us looks like. Also make sure, and that's a really important point, make sure that your deployment process is fully automated, because with the growth of an environment, the duration of a deployment increases a lot. And at some point, the deployment will easily take 12 to 24 hours, and you really don't want to attend that the whole time. So also make sure that the alerts are also well integrated and are alerting you when you are deploying, so you don't need to attend that. As Fabio already said, make sure that your deployments are 100% reproducible. So make sure that you standardize everything. Even if you have different foundation, try to keep them really the same. Try to not make them diverge too much. Because you have the same upgrade path, you have the same testing, and hopefully something reproducible. And yeah, everything should work offline as well. I'm not sure if you mentioned that, probably yes. So this is how one of our deployment pipeline looks like from a customer. You don't see all the cell blocks because they didn't fit on a screen, but you probably get an impression on how we do it. You see the cloud releases there, and we mainly maintain this Cloud Foundry pipeline and the core on the right, which it consists very much of the base components like the BOSH itself, console, Docker registry, and yeah, pretty much those things.
Yeah, okay. Which slide is that? This one. A few things about pipelines, how to pipeline or how to not pipeline. One thing we've learned is that it's a good practice to have, when you have like a long pipeline chain of deployments or whatever, is to have like a trigger resource for it, right? You need some way to trigger this pipeline chain. And what we've learned is that it's actually very useful to have a Git repository for that, whose like only purpose is to trigger this pipeline. Don't use releases or versions as triggers, because if you have a deployment pipeline and let's say you want to just deploy the last step again of this whole deployment chain, you would need to go through everything if you want to change the versions, if that's like your dependency to go through the chain. But if you have just a trigger resource, then you can just trigger the last step. You can still select independently the version of whatever your input is, whatever BOSH release or cloud release you want to deploy. So yeah, using a Git resource or repository is actually very useful as input for deployment pipelines. And you can also use the Git resource to chain together completely different pipelines actually based on a commit they do, and the other pipeline picks up this commit and sees it needs to start and so on. So you can coordinate pipelines even through Git repositories. On the other hand, though, we also have, of course, a lot of build pipelines, and these are actually kind of the opposite. Here you want to have this pipeline as rigid as possible. It should enforce what version goes through the pipeline. So you always want to have like the same release version or the same artifact be the one that goes through the pipeline and not change in between, obviously, since you're like building and testing this thing to verify everything is fine. You don't want it to change. So here you should use versions as input or releases or artifacts. Another point, Andrea mentioned it briefly just before, is you need to have everything offline available. It's also very important for having a release management system like we do. So you should not rely on BOSH.io and GitHub or anything upstream directly. You should mirror and vendor everything, just like you do in software development, where you should vendor your Ruby gems or your Golang packages. You should vendor your BOSH releases and stem cells. So you should have a company local S3, for example, and have some pipelines in a lab or dev environment which tracks everything from upstream and then mirrors it onto your local S3. And that's actually what we use as artifacts in our cloud release repository. So we're sure we have everything offline available, or well, offline from our perspective. And then this way we can also deploy in customer environments that don't have internet access at all, because everything is on our internal S3 storage. So this offline availability really is one of the key points to have a proper release management system to be able to build this, and to be able to be confident that you can always redeploy the same thing anywhere, that nothing changes in between, and you have all these versions available, and everything is like really 100% reproducible and redeployable in the same way. Because as I mentioned before, all our environments we have, they look exactly the same. We have one pipeline, we just trigger it, and they can grab all these artifacts from our own mirrored S3 storage, basically. And that's the way such a small team as we are can actually manage so many multiple dozens of full-fledged environments with all the stuff that's going on there.
As we continuously integrate the latest upstream components, it's really necessary to have some reliable tests in place. And what we do in dev environments, we focus on unit and integration tests. Also part of end-to-end tests are taking place there, but the main focus in the dev environment really relies on the CF acceptance tests. Once we're in the int, we execute the integration and the end-to-end tests for sure. And our end-to-end tests, as I mentioned before, they're really self-built. It's built based on the Ruby RSpec, so it's everything fully self-developed, and we continuously improve and extend those test cases based on incidents, on regressions, on edge cases, on whatever we have. Really special cases. So that's always an ongoing story to extend that. It also includes the absent services, so it should be covered everything. We made that. We first had like a dedicated testing team which just tested every release, but we kind of thought like it's the better thing to automate that as well, so we just did it like this. So now we have prepared like 3 very frequently asked questions to our site, so we thought like we're gonna bring them up here in our presentation already. I think Fabio will start with the first one.
So a common question is, how do you mitigate the single point of failure of a single BOSH director managing multiple AZs? Because as you've seen in the picture in the beginning, we have 3 physical AZs basically, and as you might know, BOSH is not HA yet. Maybe it will never be, but who knows? Well, one thing is what we do is we use DNS host names for our BOSH. And in pretty much any example you will see online or the BOSH deployment or anywhere, it's always based on IPs, but that would be very bad if we had to move around our BOSH director. And if we move our BOSH director from one AZ to another one, we cannot have the same IP because they're like physically different locations. And we simply thought, hey, there's this thing called DNS. Have you heard of it before? Yeah, probably. So our BOSH propagates its DNS name to the BOSH agent of every deployed VM, and then we can just move around BOSH to a different IP, and all the deployed VMs, they will just find BOSH again, or our certificates are based on this host name and not the IP, and that's what we can do. And also we use an external blob store, of course, for BOSH, which is our company internal S3. And now here I'm contradicting myself, actually. In the past, we also had the external Galera cluster for the BOSH database, but we've switched to the co-located within the BOSH VM, the Postgres. We just make sure we have regular backups, so in case we need to redeploy a BOSH director on a different AZ, we can spin it up very fast, and we will have almost no data loss. Yeah.
Well, so how do we handle multi-cloud Cloud Foundry deployments? And I'm not sure if we all have the same understanding of multi-cloud, but for us it doesn't necessarily mean that you have like different cloud provider or anything. And for us it's also necessary that we don't have like multiple installation per cloud. It's like we have one single installation stretched over those availability zones or clouds or whatever. So our recommendation is to just use one stretched CF deployment over those data centers.
Yeah, we've been asked this question before. How how do we handle this multi-cloud AEC connectivity? And well, what we have is like, so we have these 3 availability zones, and we just have one flat /16 network that spans over them, and each availability zone gets assigned, I think, a /19 block out of it. And now the thing is, I actually don't know how the connectivity between the 3 ACs has been set up, because I'm not a network expert, but let's say it certainly helps to be working for a telco company, because apparently we know how to do that. So yeah, but I'm not the expert on it.
So with that, we want to say thank you for your attention, and we are now open to question. I will move around with the micro so the answer also get captured on the video afterwards. So feel free to ask if there are questions open.
So there's a question.
You mentioned you had the Backman and the AMC developed yourself. Are those also publicly available?
No, not yet or not at all. The AMC tool probably would not be very feasible to put public, because it's very specific to our environments. It makes a lot of assumptions on how something needs to be and so on. But just yesterday, we actually had the discussion about open sourcing the Backman, because that one is extremely generic and maybe some people could benefit from it. So we were thinking about open sourcing that one, yeah.
What is the typical customer who are using Cloud Foundry in a cloud?
Sorry, can you repeat?
What is a typical customer?
The typical customer. Well, I don't know how to. We have all kinds of customers. I would say your average. We try to cater mostly to the enterprise market, and our customers in that regard are mostly bigger enterprise companies that just don't want to manage this platform themselves. So we just offer a managed platform as a service, and yeah, they are big companies, but they don't want to manage this platform themselves. That's basically our target market, or where we have some leeway into. And of course, we also do the whole Swiss thing, where we say, yeah, we're a Swiss company, all our data is based in Switzerland, so we can cater to mainly to Swiss companies. That's our market.
Can you give me more insight in the moment it became more efficient to write your own manifest instead of applying YOS files and maintaining them?
It's not just that we think it's better to completely write your own templates. It's also actually this started for historical reasons with us, because we were pretty early on using the open source Cloud Foundry, the CF release back then. And it was still, I think, SPIF templates, and SPIF really was a pain in the ass to make it work. And it was hard to reason about how the merge process of these different templates work. At some point, Stark and Dwayne Spruce came along, and we pretty much, from that point on, we started completely writing our own deployment manifest templates from scratch using Spruce. So we have our own merge process. Everything is automated. We have like a template format that we adhere to when writing this template. And I think it actually has proven really beneficial, because we really had to reason about every single component's properties. Why is it set to this? What does this property do? How do these... Because Cloud Foundry, it consists of many, many different components, and we had to reason about how they interact with each other, what does it mean, and so on. For us, it was really, in the beginning, it was quite annoying, and it took a lot of effort, but it turned out to be great, because we have a better understanding of the whole system because of that.
Can you describe the workflow when one AZ fails and the BOSH director multi-CPI failovers? potentially to the AZ which is working and try to talk to the AZ unavailable? Or how does it work for you?
Yeah, if one AZ fails, pretty much nothing happens. I mean, the big deployments, BOSH goes into meltdown mode, the resurrector will not do anything anymore, and all our deployments, they're like in multiples of 3. So because we use the 3 AZs, we always have at least 3 types of VMs for everything, and the loss of one AZ is actually not noticeable at all. At least for Cloud Foundry, there really is no downtime, nothing happens. I mean, some apps will maybe moved around, but we always encourage our customers to have more than one instance anyway. And as far as I know, the scheduler tries to spread them out over AZs. So the loss of an AZ really isn't an issue. And usually, if it's the one AZ where the BOSH director itself is located, we don't even bother moving or migrating the BOSH director and spinning it up again. If it's just like for one day or something, that's completely fine.
So no impact on data plane and control plane, you just wait?
Yeah. Of course, I mean, if it takes very long and if like an AZ, like a data center exploded or whatever, then we might think about what to do. But usually if it's just for like 24 hours, we don't do anything, we just wait.
Okay, thank you.
So you said you will just wait. Can you please elaborate the connection between an AZ outage and the singleton database you mentioned earlier?
The one for the BOSH director, or?
No, the MySQL one, or wasn't it?
The Postgres stuff. Yeah, there are some services which, just like BOSH, are single instance, but they're not that important, I would say. We would have the issue of not being able to provision new BOSH-based services, because we also have multiple, what we call service BOSHs, which are also deployed, and those in turn, they are fronted by a service broker and they deploy databases, and we lose the ability, or our customers would lose the ability to provision new types of these services. So that also would be an issue, yes.
I'm not talking about the provisioning. I mean, if you have a single instance, for sure, if the AZ is down, you have the downtime, or?
Yeah, but what I meant is these service BOSHs, they have a single instance of a database. The database offering we have for the customers, they're always also, they still use the Galera and they still have 3 nodes and so on. The single instance is really only on components which are not so important and they can survive being a day down. And another thing we have is the app autoscaler, the open source one. That one has a single instance of a Postgres, and it's true if the AZ where this Postgres database would be, our autoscaling service would be down. And we would have to decide on what to do there if we need to spin up this Postgres database in a different AZ. Yes, that's true. But we think like this service can afford to be down for one day. So the single instance, if it goes down, it's all used in deployments where it's not so important to be up all the time.
I don't see any more questions. So have a nice day. Enjoy it.